All right, let's have a look at similar triangles. So, similar to congruent triangles, there are tests for similarity. And in fact, the tests are exactly the same. Because when you think about it, all congruence is a special case of similar triangles. And it's the case when the ratio of the sides is 1 to 1. Other than that, it's identical. So, we do in fact have corresponding sides are in proportion. Now, the reason I usually put down then is side, side, side. I mean, that is the reason we're using it. It's the same as the congruent triangle one. But the difference is we have a ratio. So I don't just put side, side, side. I'll put side, 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 and then I'll put down the ratio A to B, whatever the ratio of the sides are. So side angle side. So again, same idea, but the sides will be in the ratio A to B. Now, the third one's a bit different, of course, because it's angle, angle, side. And you can't really have one side being in the same ratio. Same ratio as what? When you've only got one side. And as I mentioned yesterday, we only need 2 angles for similarity, because that's what stopped us from using it to prove congruence. As soon as we had 2 angles, by angle sum of a triangle, the third angle is going to be the same. So therefore they are, in fact, similar shapes. So all 3 angles are the same, but it's sufficient just to show 2 angles. So sometimes we put down AA. The other reason sometimes people put down is equiangular. You might see that in some proofs from time to time. Yeah.
Say stuff like all matching angles are equal.
Yeah, look, if you want to write down all matching angles are equal, that's fine too. I mean, it's saying the same thing, isn't it? Yeah. All right, so let's do one. Find AD. So we've got some sides here. Let's prove some similarity. DAE is the same as BAC, because in fact they are the same angle. It's just a different way of naming that angle. And EDA is the same as CBA, corresponding angles. So I've got 2 angles. And you'll probably remember from similar triangles that the vast majority seem to be showing those angles are the same. So there we go. I've got angle, angle, or equiangular. So now I can say the sides are in the same ratio. I sometimes find it easier to draw the 2 triangles side by side in like corresponding position. So it's very clear to me then which sides correspond to which, so I don't muck it up. So I now know, well, it's AD I want to find. That corresponds to AB in the other triangle. It's in that position. And AE is in the same position as AC. So that would be the ratio of the sides in similar triangles, subbing in the info we've been given, and we get our length, 10 centimetres. Keep in mind, you might get a question. It's rare, but you might get a question about area and volume. So if sides are in the ratio A to B, it means their areas will be in the ratio A squared to B squared. Because all of the sides are in the ratio A to B, so when you multiply the sides together to find your area, you end up squaring that ratio. And so similar thing, if it's a solid we're talking about and we want to find volume, then the volumes will be in the ratio A cubed to B cubed, because you would have got each of the sides and gone length, breadth, height. So multiplied that ratio by itself 3 times.